Hi everyone, how are you all? Today I have brought you chapter 9 matrices. Okay, it has taken me some 4 or 5 days because I had some personal reasons, children, so I couldn't bring it earlier. But now you will get 2 or 3 slides regularly in 1 or 2 days. Okay, so chapter 9 matrices. I think if you have studied this chapter, then it will be very easy for you because the chapter is not at all difficult. Okay, only that you have to keep in mind that when you write the question correctly, means you put the plus mark and the minus mark and the or the plus sign and the negative sign and all, and copy the numbers correctly. Okay, that is all what is required in the matrices. And read the question 2 times and write it correctly. And also while doing the answers, you do the calculations and write the answer correctly. So do recheck. Okay, now this chapter has been taken from Concise Mathematics Selina publication class 10 2024 edition by R.K. Bansal. Okay children, and it is for ICSC board. So coming to the next slide children, the point number 9 plus 1, sorry 9.1. What does it say children? What is a matrix? Okay, a matrix is a rectangular arrangement of numbers arranged in rows and columns. Okay, a matrix is a rectangular arrangement, means there are rows and columns in it where the numbers are placed, and it is a rectangular arrangement, means square. It can be a square also, it can be a rectangle also. Okay, what is the plural of matrix? Plural of matrix is matrices. Each member or entity in a matrix is called its element. In a matrix, the horizontal lines are called rows, whereas the vertical lines are called columns. Understood, children? Each member is called an element, like 5 and 1 in the first matrix, 5, 3, 1 and 2 in the second one, and 5, 3, 2 in the third matrix. Okay. In a matrix, the horizontal lines means the lines which are drawn like this. I'll point out to you, like these are horizontal lines. Okay, these are horizontal lines. Okay, and these are called rows, whereas these two lines, if they cover these two numbers, these are called columns. Okay, these are called columns. Now coming to the next slide children. Now coming to the point number 9.2. Okay, what does it say about? It says about the order of a matrix. Okay, what is an order of a matrix? We will study this in the definition. The order of a matrix is equal to number of rows in it into number of columns in it. Okay, rows are, I said that are the rows are means the numbers are written horizontally, and columns where the numbers are written vertically. That is, if a matrix has m number of rows and n number of columns, its order is written as m into n and is read as m by n. Okay, so we read it as m by n, but we write it as m into n. Okay, consider the matrix 2 1 5 3 minus 2 7. In the first row children, what you can see, the numbers are 2 and 5. In the second row there are 3 minus 2 and 7. In the first column children, the numbers are 2 and 3. In the second column the numbers are 1 and minus 2, and in the third column they are 5 and 7. Okay, therefore it has 2 rows and 3 columns, hence its order is equal to 2 into 3, read as 2 by 3. Sorry, not 2 into 3, 2 by 3, that is 2 into 3 is, it is written as 2 into 3, but it is read as 2 by 3. Okay. Okay. There is a point which is important children. While stating the order of a matrix, the number of rows is given first and then the number of columns. Always you have to write the number of rows first and then only you have to write the number of columns. Okay. Notation. Matrices in general are denoted by capital letter. For example, if A is a matrix with m rows and n columns, okay, then it is written as A m by n. Okay, how it is written? A, capital A, and m by n is written at the bottom. Okay. Now similarly, B 5 by 3 means a matrix B with 5 rows and 3 columns. Okay. The point number 9.3, children, elements of a matrix. What are the elements of a matrix? We just read what are the elements of a matrix. We know that each number or entity that is present in a matrix is called its element. Okay. What is the total number of elements in a matrix, children? The total number of elements in a matrix is equal to the product of its number of rows and number of columns. That is, if a matrix has 4 rows and 6 columns, the number of elements in it is equal to 4 into 6, that is equal to 24. Okay, children? Consider matrix A that is equal to 2, 4, minus 3, 0, 1, 2. Since there are 2 rows and 3 columns in matrix A, so the number of elements in it is equal to 2 into 3 is equal to 6. If a matrix has 8 elements, then it may have 1 row and 8 columns, and the number of elements is equal to 1 into 8, that is equal to 8. Okay, it can be of any ways. Okay, see, 1 row 8 columns means 1 row and 8 columns. Okay, or it can have 2 rows and 4 columns, that is of the order 2 into 4, and again it elements will be, number of elements will be equal to 8 because it is equal to rows multiplied by columns. Okay, the number of elements is equal to 4 rows and 2 columns, its order is equal to 4 into 2 and the number of elements is equal to 8. 8 rows and 1 column, its order is equal to 8 into 1 and the number of elements is equal to 8 again. Okay, clear, children? You can choose another matrix. Suppose you are choosing 6. Okay, then also you will, what you will find, that the number of elements are 1 into 6 or 2 into 3, 3 into 2 or 6 into 1. Okay, children? Now coming to the next slide, children. Point number 9.4. Okay, what is that? It is saying types of matrices. There are different types of matrices, children, and we are going to study each of them one by one. Okay, the first one is row matrix. What is a row matrix? A matrix which has only one row is called a row matrix. Okay, example, see, A and B. There is only one row, however, there are 2 columns in it. Okay, so that is called a row matrix. This matrix has 1 row and 2 columns and its order is 1 by 2. A row matrix is also called a row vector. Row vector means it has only 1 row. Okay. Now coming to the second type of matrix. The second type of matrix is a column matrix. A matrix which has only 1 column is called a column matrix. Okay, children? That is, there can be any number of rows, but the column is only 1. Okay. See the example, children. A, B, C. They are written vertically. First row, second row, third row, and there is a single column. Therefore, the above matrix is a column matrix and its order is 3 by 1. Why, children? Why 3 by 1? Because we have to take the rows first and then the column. Okay, order is always expressed by mentioning the rows first and then the column. A column matrix is also called a column vector. Now coming to The third type of matrix, children, that is square matrix. A matrix which has equal number of rows and columns is called a square matrix. The number of rows and columns should be equal. That is, if you see the example A, B, C, D, the first row has A and B, second row has C and D, and first column has A and C, and second column has B and D. Therefore, the order of the matrix is 2 by 2. Okay, both the rows and columns are equal. That is why it is a square matrix. Similarly, if we have a matrix like 5, 7, 4, 2, -1, 0, 0, 3, 4, is a square matrix of the order 3 by 3. Okay, because you can see there are 3 rows and 3 columns. Now coming to the fourth type of matrix, children, that is a rectangular matrix. A matrix in which the number of rows are not equal to the number of columns is called a rectangular matrix. How, children? Because if in a rectangle, the width is not equal to the length. You know that? Okay, in that way only, in the rectangular matrix, number of rows are not equal to the number of columns. Okay, see here the example, children. 2, 4, 7, 1, 0, 5. What is the order of the matrix, children? 2 by 3. Now 4, 5, 6, 7, 8, 9. Order of the matrix is 3 by 2. Okay, 0 or, so they are both not square matrices, but they are rectangular matrices because they ordered, because the rows are not equal to the number of columns. Okay, now coming to zero or null matrix. What is a zero or null matrix? If each element of a matrix is 0, it is called a zero or null matrix. Example, 0, 0, and in the first row, and here in both the first column there is 0, 0, and here there is a 2 by 2 matrix where all the elements are 0. Now coming to what is a diagonal matrix. Okay, a square matrix which has all its elements as 0 except those on the leading principal diagonal is called a diagonal matrix. What is a diagonal matrix, children? Again I am telling you, it is a square matrix. First condition is that it should be a square matrix which has all the elements 0. Okay, all the elements are 0 except those on the leading or principal diagonal is called a diagonal matrix. Okay, for example, see the matrix here 2, 0, 0, 4. So here you can see the diagonal at the diagonal. What is a leading diagonal, children? Leading diagonal is the diagonal which is taken from the leftmost corner to the rightmost corner of a matrix. Okay, so 2 and 4 is the diagonal, and the other elements are 0, and there are 2 elements on the diagonal. Now again we will see 5, 0, 0, 0, 8, 0, 0, 0, -7. Then also here also we see 5, 8 and -7 are on the leading diagonal. Therefore the matrix is a diagonal matrix. Okay, so there is a note, children. In a square matrix, the leading or principal diagonal means the diagonal from top left to the bottom right. I have already told you about this thing. Okay, children. Now coming to the seventh type of matrix, which is unit or identity matrix. A diagonal matrix which has each element of its leading diagonal as equal to 1 or unity is known as identity matrix. That is, it has to be a diagonal matrix, and on the diagonal, principal diagonal, all the numbers should be equal to 1. Okay, and the rest of the numbers will be equal to 0 as it is a diagonal matrix. Okay, and it is also known as unit matrix. It is denoted by I. In other words, it is a square matrix in which each element in its leading diagonal is equal to 1 and all other elements are equal to 0. It is self-explanatory, children. Example 1, 0, 0, 1. or 1 0 0 0 1 0 0 0 1. You can see that how on the principal diagonal the numbers are 1 unity, 1 or unity. Okay. Now coming to the point number 9.5 children, transpose of a matrix. Transpose of a matrix is a matrix obtained by interchanging its rows and columns. If A is a matrix, then its transpose is denoted by A and T is placed at the power point. Okay, means where we put the power of a number. So if A is equal to 2, 3, 1, 0, 4, 7, then its transpose matrix AT is equal to 2, 0. The rows will become columns and the columns will become rows. Okay. So 2, 0 is the column, it will become row, first row. 3, 4 is the second column, it will become the second row, 3, 4. 1 and 7 are the third column, they will become the third. Sorry, 1 and 7 are the third column, yes, and they will become the third row. Okay, so what we will get? 2 0 3 4 1 7. So what do you see? The order of the matrix, in the first case was 2 into 3, and order of the matrix in the third case, in the transpose case, is 3 into 3 by 2. That is, it has been uh, changed, means it has become opposite of it. 2 by 3 has been changed to 3 by 2. Okay. Now children, studying about the equality of matrices. This is point number 9.6. Two matrices are said to be equal if both the matrices are of the same order. Secondly, the corresponding elements of both the matrices are equal. That is, both the matrices are of the same order, have to be of the same order. There are two conditions for the equality, and the corresponding elements of both the matrices are equal. Therefore, if A is equal to 2, 3, 1, 5 and B is equal to 2, 3, 1, 5, then A is equal to B, because A is also of the order 2 by 2 and B is also of the order 2 by 2. And see the elements, the corresponding elements means like in the first row, first column, the number is 2. First row, second column, the number is 3. Then second row, first column, the number is 1. Then second row, second column, the number is 5. Okay. Then A is equal to B. Now coming to question children, find the value of x, y, A and B if A by x minus 2, y, A by 2, B plus 1 is equal to 0, 3, 1, 5. Okay. Since the matrices are equal, their corresponding elements are equal. X minus 2 is equal to 0. Therefore, x is equal to 2. Okay, children? By the equality of matrices, we can say that since the matrices are equal, the corresponding angles are equal. Sorry, corresponding elements are equal. So, x minus 2 is equal to 0. Therefore, x is equal to 2. Now children, from the matrices you can see that y is equal to 3. A by 2 is equal to 1 implies that A is equal to 2. And B plus 1 is equal to 5 implies that B is equal to 4. Okay. So you got the answer for all the variables, that is x, y, A and B. Okay. Now coming to the addition of matrices, that is point number 9.7. Note compatibility for addition of matrices. What is the compatibility for addition of matrices? That two matrices can be only added if they are of the same order. Okay, if they are not of the same order, it is not possible to add that is one condition. Okay, to add two matrices means to add the corresponding elements of both the matrices. Okay, means that if you want to add two matrices, we have to add the corresponding elements. Example, if A is equal to 5, 4, 2, 1 and B is equal to 3, 2, 1, 4, A plus B is equal to 5 plus 3, 4 plus 2, 2 plus 1 and 1 plus 4. Therefore, A plus B is equal to 8, 6, 3 and 5. Okay. I hope you are understanding, children. There is nothing very difficult here. 5 has been added to, see, 5 has been added with 3. 5 plus 3 we got 8. 4 has been added to 2 because they and we got 6. 2 has been added with 1 and we got 3. 1 has been added with 4 and we got here 5. Okay, children, that is the answer. Now coming to the next slide, children. Subtraction of matrices. What is the condition for the subtraction of matrices? This is the point number 9.8. The same rule and method is used for the subtraction of matrices as was used for addition of matrices. That is, they in the order of the matrices should be equal and the corresponding elements are subtracted. Okay. If A is equal to 5, 4, 2, 1 and B is equal to 3, 0, 4, 2, then A minus B is equal to 5, 4, 2, 1 minus 3, 0, 4, 2. Then what you will do, children? You will write here 5 minus 3, then 4 minus 0, then 2 minus 4 and 1 minus 2. Okay. When you write these, then you what will get the answer? 5 minus 3 as 2, 4 minus 0 as 4, 2 minus 4 as minus 2 and 1 minus 2 as minus 1. Okay, children. Now coming to the question, children, let A is equal to 5, 4, 3 minus 2, B is equal to minus 3, 0, 4, 2 and C is equal to 1 minus 3, 0, 2. Then find A plus B and B plus A. Okay, first question. Second question is A plus B the whole bracket plus C and A plus B plus C the whole bracket. Now is A plus B is equal to B plus A? And the fourth question is A plus B plus C is equal to A plus B plus C the whole bracket. Okay. In each case, write the conclusion, if any, that you can draw. Okay. So let us come to let us solve these questions, children. How? See, first one is A plus B. We have to show that what is A plus B is equal to B plus A. See, A plus B, what is the answer? 5, 4, 3 minus 2 plus minus 3, 0, 1, 4. Okay. Here, what you will do? 5 plus minus 3, 5, 4 plus 0, 3 plus 1, minus 2 plus 4. Okay. I am doing this for you only, children, this thing. Subtraction means addition portion. Okay. And you should also do it in the exam, because when you do it this mentally now, what happens that sometimes we do it like we do subtract it, or we do the numbers get interchanged. Okay, so it will take no time to write. You only 1 or 2 questions will come and it will not take much time for you to do this, to write this thing. Okay, and then you can write the answer. It is very easy from here only that you can write it answer, that 5 minus 3 is equal to 2. But no, you should do like this so that in the exam you don't make a mistake. Okay, if your teacher sees this also, she will give you marks that you have done this correctly. Okay, there is a marks for every step in mathematics. Now what you see, 5 minus 3 is 2, 4, then 3 plus 1 is 4 and 4 minus 2 is 2. Therefore the answer is 2, 4, 4, 2. Now coming to B plus A, children, minus 3, 0, 1, 4 plus 5, 4, 3 minus 2. What we get, children? Here I have done it directly. 5 minus 3 is 2, 0 plus 4 is 4, 3 plus 1 is 4 and 4 minus 2 is 2. Okay, so therefore we got the answer that 2, 4, 4, 2. Therefore A plus B is also equal to 2, 4, 4, 2 and B plus A is equal to also 2, 4, 4, 2. What is the second question? A plus B the whole bracket plus C is equal to and then we have to show is equal to A plus bracket B plus C. Okay, A plus B plus C. First we will do A plus B. Okay, what is A plus B is equal to 2, 4, 4, 2. We know the answer of A plus B from the first equation, that first question, that it is equal to 2, 4, 4, 2. Now you add 1 minus 3, 0, 2, that is the value of C to it, and then we will get the answer as 3, 1, 4, 4. Now we have to add B plus C. Okay, because we haven't found the answer of B plus C. B plus C is minus 3014 plus 1 minus 302. Okay, so it is equal to minus 2, minus 3 plus 1 is equal to minus 2, 0 minus 3 is equal to minus 3, 1 plus 0 is equal to 1, and 4 plus 2 is equal to 6. Now if you add A also to this, what you will get? 5, 4, 3 minus 2 plus minus 2 minus 3, 1, 6 is equal to 5 minus 2 is equal to 3. 4 plus 4 minus 3 is equal to 1. 3 minus 2, 3 plus 1 is equal to 4, and minus 2 plus 6 is equal to 4. So you see here, A plus B plus C, the whole the previous A plus B plus C is equal to the second one, A plus bracket B plus C. Okay, so the both of them are equal. So the for the third and fourth answer, you will get answer as yes. Okay, yes. So third answer, what you see, A plus B is equal to B plus A. We have found out from the first question itself. Therefore, what is the conclusion? That addition of matrices is commutative. Okay, and fourth question, yes, fourth also is correct, because bracket A plus B plus C is equal to A plus bracket B plus C. Okay, we say that addition of matrices is associative, means we can add them in any order. Okay, and addition of matrices is commutative, means if we add either A plus B or we add B plus A, they are both the same. Okay, now children, we have written the same thing, the conclusions which we have drawn earlier from the previous slide, that remember. First one, that the order of the matrix obtained as a result of addition or subtraction is same as the order of the matrices added or subtracted. Okay, if you add two matrices of the order 2 by 2, then you will get a matrix of the order 2 by 2 only. Okay, if you add if you subtract two matrices of the order 3 by 3, then you will also get the resultant matrix will be of the order 3 by 3. Okay, if A, B and C are the matrices of the same order, then A plus B is equal to, if A, B and C are the matrices of the same order, then A plus B is equal to B plus A. This we have proved, and it is commutative. Okay, and bracket A plus B bracket close plus C is equal to A plus bracket B plus C bracket close. That is A plus B plus C is equal to, that is associative. Okay, the addition is associative. Okay, coming to the third part of the question, children, A plus X is equal to B implies that X is equal to B minus A. This means that this is the third conclusion which we have drawn, that if A plus X is equal to B, X is any matrix. Okay, X is any matrix, it is a variable matrix, and is equal to B minus A. If A is equal to 5, 4, 3 minus 1, B is equal to 2, 1, 0, 4, and C is equal to minus 3, 2, 1, 0, find A plus C, B minus A, and A plus B minus C. Okay, here we are not taking a unknown matrix till now. Okay, we will take it in the further questions. So what is the answer for A plus C? 5, 4, 3 minus 1 plus minus 3, 2, 1, 0. That is equal to 2, 6, 4 plus 2, 6, 3 plus 1, 4, and minus 1 plus 0 is equal to minus 1. Okay, this is the first answer. Now B minus A, means 2 1 0 4, this is the B matrix, minus 5 4 3 minus 1, that is the A matrix, is equal to, now till form subtraction you can take this, you can do this in, means you can open this 2 minus 5 and then 1 minus 4 and 0 minus 3 and 4 plus 1. Okay, because minus into minus it will become plus 1, is equal to minus 5 plus 2 is minus 3, minus 4 1 plus 1 is equal to minus 3, minus 0 minus 3 is equal to minus 3, and 4 plus 1 is equal to 5. Children, you should do this thing, because it is sometimes you will make there is possibility of making mistakes in doing the calculations. Okay, only for this reason you should try to do wherever you have confusion, or you should make it a habit to do it. Okay, now coming to the question number 3rd, A plus B minus C. 5 4 3 minus 1 plus 2 1 0 4 minus 3 minus 3 2 1 0. Now first adding the first two, we get 5 plus 2 7, 4 plus 1 5, 3 plus 0 3, and 4 minus 1 3. Now minus 3 2 1 0, it will be equal to, what is 7 plus 3, minus into minus plus 3, see I have written directly here, 7 plus 3 is equal to 10, 5 minus 2 is equal to 3, 3 minus 1 is equal to 2, and 3 minus 0 is equal to 3. Therefore the answer is 10 3 2 3. Okay, okay children, now coming to matrix question number 4. Okay children, if the matrix, what does it say? If matrix A is equal to 2 1 3 4 minus 3 2 and B is equal to 3 minus 2 7 and 4, find the transpose matrix, that is AT and BT. If possible, find A plus AT and second B plus BT. Okay, if it is possible, you have to find that. Okay, now what is the first order of the first matrix? It is a rectangular matrix. You can see that it is of the order 2 into 3. So if it is if the order is 2 into 3, therefore its transpose order will be 3 into 2. So therefore 2 4 will be the first row, 1 minus 3 will be the second row, third row will be 3 by 3 and 2. Okay, therefore AT is of the order 3 by 2. And what is the transverse of BT will be equal to, because B is equal to 2 by 2 matrix, therefore we will, in transpose also we will get a 2 by 2 matrix, that is 3 minus 2 7 4. Will change the order of the will change the rows into columns and columns into rows. Therefore the transpose matrix will be equal to 3 7 minus 2 4. Okay, now if we see A and A by AT, we see that they are not possible, as both are of different orders, that is 2 by 3 and 3 by 2 respectively. Okay, therefore we cannot add both of these matrices. It is not possible. Okay, you can see that. I hope you have understood. Here children, what we see in the second part, that B plus B transpose is possible as both are of the same order, that is 2 by 2. B plus BT is equal to 3 minus 2 7 4 plus 3 7 minus 2 4, and it will give you the answer as 3 plus 3 is equal to 6, minus 2 plus 7 is equal to 5, 7 minus 2 is again 5, and 4 plus 4 is equal to 8. Okay, and talking about the additive identity now, which is the 9.9, point number 9.9. In ordinary numbers, 0 is the additive identity, as 5 plus 0 is equal to 0 plus 5. That means that if you add 0 to any number, the number remains same. Okay, if we take 0 plus minus 3, it will be equal to minus 3 plus 0, which will be equal to minus 3. Okay, therefore we get the same quantity when 0 is added to it. Okay. Similarly, in the case of matrices, if null or zero matrix of the same order is added to a matrix of the same order, the matrix remains unaltered. So null matrix is said to be the additive identity in matrices. Okay. Means if you have if you are adding a null matrix contains all the elements as 0. Okay. If you add null matrix of the same order, which is to the order to the matrix which has the same order of the null matrix, then the matrix will remain unaltered or matrix will remain the same. Okay. So therefore the null matrix is said to be the additive identity in matrices. Okay, children. Now example, see first example, 4607 plus 0000. It will give you 4607 only. Okay. And if we add 0000 plus 4607, then also we will get 4607. Okay. Then 5 minus 4 plus, here there is 1 into 2 matrix, 1 by 2. So here also, here this order will be 1 by 2 only, that is 0 0. Therefore what we get the answer as 5 minus 4. Okay. It is equal to, if you add the null matrix in the beginning or after, the same answer will be the same answer you will get. Plus 5 minus 4 is equal to 5 minus 4, which is same as the question matrix given. Okay. So the null matrix does not make any change in the value of the matrix. Okay. What now, coming to the point number 9.10, children, additive inverse. If A and B are two matrices of the same order such that A plus B is equal to B plus A is equal to a null matrix, A is said to be the additive inverse of B and B is said to be the additive inverse of A. Are you understanding this, children? See, if A and B are two matrices and adding A and B gives you a null matrix, that is a zero matrix. Okay. So what happens is that if A plus B and B plus A gives you a null matrix, what we can do, say that we can say that A plus B is equal to B plus A is equal to null matrix. So if we add, B is the additive inverse of A or A is the additive inverse of B, because they will have the negative values of the other matrix. Okay. In fact, additive inverse of matrix A is negative of a matrix. I told you that additive inverse, in case of additive inverse, they have to get a null matrix. So additive inverse of matrix A is a negative matrix, that is minus A. Example, if A is equal to 4 minus 2 minus 3 7, then its additive inverse is equal to minus A is equal to minus 4 2 3 minus 7. Okay. And A plus minus A, what is A plus minus minus A? You have found out minus 4 2 minus 3 and 7. So A plus minus A is, if you add this, then we get the answer as a null matrix. 4 plus minus 4 minus 2 plus 2 minus 3 plus 3 7 plus minus 7. All of them are equal to 0 only. They give the value as 0 only. So B here can be said as minus A. That is why it is called additive inverse of A. Okay. Note, if O is a 0, is the 0 matrix or is a null matrix of the same order as matrix A, then A plus O is equal to O plus A is equal to A. If you add a null matrix to a matrix of the same order, then you get the same matrix. Okay, we have done this. And A plus minus A is equal to minus A plus A is equal to null matrix. That is, we have done just before this, that A plus minus A is equal to minus A plus A is equal to 0. Now 9.11, solving matrix equations. Okay, how to solve matrix equations. If A is equal to 8, 6, minus 2, 4 and B is equal to 3, 5, minus 3, 5, 1, 0, then solve for 2 by 2 matrix. Okay. A plus X is equal to B and X minus B is equal to A. Answer, first one, A plus X is equal to B. So this is the X is the unknown matrix we have to find, and X value will be equal to B minus A. So is equal to minus 3, 5, 1, 0. B value is minus 3, 5, 1, 0 and A value is 8, 6, minus 2, 4. Therefore, when we subtract, minus 3 minus 8 will give you minus 11, 5 minus 6 will give you minus 1, 1 minus 1 plus 2 will give you 3, 0 minus 4 will give you minus 4. That is the answer. Okay. And for the second part, X minus B is equal to A. Simply it is X, it will be equal to A plus B. Well, it is a simple addition, children. 8, 6 minus 2, 4 plus minus 3, 5, 1, 0. Therefore, 8 minus 3 is equal to 5. 6 plus 5 is equal to 11. 1 minus 2 is equal to minus 1 and 4 plus 0 is equal to 4. Okay. So, we have seen that additive inverse also, transpose also, and equations on matrices also. So thank you, children. Thanks a lot for watching my video, and please comment, share, subscribe and like my video. If you have not subscribed to now till now, do subscribe, children, because all my videos will be according to the class 10th board exams and you will get benefit from it. I am sure about it. Okay, I'm 100% sure that you will, if you go through my slides, you will definitely benefit from it, and you can do the exercises which are given in your book very easily. Okay, so again thanking you, but please, children, please subscribe and like my channel, and whatever comment you want to give, whether it is a negative or a positive comment, please do so, and please share it among class or your classmates also, class 10 classmates, so that they can also they can also get the they can also study from the slides. Okay, so thank you again. That's all for today for this presentation. Thank you. God bless you all. Okay.